Hello and welcome to the second Func Prog Sweden this year. So the agenda for today, we have like 3 presentations. First up is Carmel bringing in OCaml to the Erlang VM by Leandro Ostera. Second presentation is ClojureScript, React with a Hiccup by David Vujic. And last but not least, Monads in JavaScript. I promise you'll have a good time by Max Nordlund. And I'll end up with the summary and also with the schedule for the spring, for the coming meetups this spring. First, we would like to thank our video sponsor and studio sponsor, Adabeat. Adabeat is a tech consultancy company based in Stockholm. Most developers have a background in functional programming. If you want to know more about Adabeat, check them up in social media or on adabeat.com. If you will have questions for today for the speakers or feedback to the speakers, please use the chat in the YouTube. And we will forward the questions to the speakers so they can answer them. Yes, with that said, let's start. So, first presentation. Carmel, bringing in OCaml to the Erlang VM by Leandro Ostera. I hoped I pronounced your last name correct.
That's right, yes.
Thank you very much. Then, just going to find your presentation. The stage is yours.
Great. Look, Ma, I'm on TV.
Yay!
Is my presentation here, I guess?
Yes. Oh, sorry.
Should I like swap screens or something?
No. Oh, it is here.
There we go. Oh, it's on the other screen. Is that a problem or?
No.
All right. Yes. Hello. Hello, everyone. My name is Leandro. Yes, and I'm going to be speaking a little bit about Carmel. I'm going to show you a statically typed functional language for the Erlang VM. Which camera should I look into? That one?
One.
Okay, 1. Thank you. Yeah, I'm a staff software engineer. I work on daily basis at Erlang Solutions. You can find me on Twitter. My handle is @leostera and as @ostera on GitHub as well. I run a company I founded called Abstract Machines, where I'm trying to build languages and software tools to think clearly. And one of the things I think about a lot these days is how to build software. So naturally, if I want to think clearly about building software, I need better tools to think about the software I'm building, right? So let's dive right into Carmel. There's a couple of goals, right, when you set out to build a programming language that I'm not inventing myself. This is stuff that I've learned from watching other people introduce their languages as well, like Rich Hickey or Jose Valim, right, with Clojure and Elixir. And the goals that I have with Carmel are to build an ML. I like ML languages in general, right? I like languages that have an expressive but sound type system. So, you know, I don't want it to be as complex, as complicated, and futuristic, if you want to call it that, as Haskell or Idris. But I also don't want it to be unsound and hard to reason about like TypeScript. I want a middle ground, something pragmatic that works, right? I want the language, right, that embraces Erlang and OTP and all of the patterns. I'm going to get the water. It's over here. There you go. Sorry, camera swaps. So I want a language that's functional because I think functionally, like that's just how my brain works when I'm coding, right? I want a language that gives me immutable data and it lets me do concurrency in a type-safe way. Concurrency is already hard, right, if you are not working in a functional way. And when you do functional concurrency, like we all do in Erlang and Elixir, and I guess Clojure to some degree as well. Yes, I see someone there saying yes, cool. Yeah, adding type safety on top of that makes it even better, even easier to understand what's happening. I need a language that sort of leverages the ecosystem. So it's not a language that invents everything from scratch. It's not its own platform. I need a language that sort of builds on top of the giants, right, that have built the Beam ecosystem already, right? We have Erlang with, I don't know, 20, 30 years of building libraries like OTP, right? And people like 99s, right? They have built the entire HTTP infrastructure for the Beam just in crazy good ways. And also from the Elixir world. And I want to be able to reuse all of that. So this language has to have a way of interoperating, right, with these Beam languages at zero cost, ideally. Maybe it will cost a little bit, but most of the time it has to be zero cost. I need a language that's free and open source, so everybody can join and communicate and contribute, right? Without anybody being able to sort of snatch it and do something else with it. And I need the language to be batteries included. I don't want to go hunting around for what's the best JSON library. I just want it to come with a JSON library. Done. Will there be better alternatives? Sure, guaranteed. Some of the community is smarter than the people building the language. Me will come up with a better library for JSON, and I'm happy for that, right? But I don't want to put the burden of figuring these things out over and over and over on everyone that's using the language. So these are some of the goals that I've had for Carmel, right? I'm going to try to answer a couple of questions that I feel will give you a good grip of why the project is structured and aimed in this direction. And we'll start with the closest one. Why an OCaml? Why do you want to bring an OCaml to the beam, right? Well, OCaml has a pragmatic, sound, and proven type system. What do I mean by that? I mean that it's built, right, to let you get shit done. So it's very pragmatic. It's not going to bring a lot of theory that is really hard to grasp and put into practice. It's going to say, this is the type safety you need to make sure that what you're doing right now works, right? It's sound, so if the program does compile, you get a certain set of guarantees, right? You know that there won't be any, for example, type errors. It's a type system after all, right? But it does also give you a series of escape hatches that you can use to be more pragmatic, right? So you have, for example, external FFIs that you have to type at your own risk. So if you're calling on some Erlang code or some C code, right, and you get the types wrong, then that may crash at runtime. But everything within the language is guaranteed to not crash at runtime because of the types. And it's also proven. It's not a new type system. This is something that has, what, 25, 30 years of industrial usage. That's millions of hours and dollars being thrown at the problem, figuring out how to make the type system scale, be correct, right? I can't build a type system from scratch and just make it as good as OCaml just by myself, right? It will take a long time. But I need now the language to be there. So that's why OCaml, right? We also have other things. For example, OCaml has a very small functional core language, right? The functional parts of OCaml are super tiny. And this was crucial at the beginning because Carmel has been mainly a solo effort. It's mainly been me outside of work getting this done. Now that's changing, thankfully. Both Nico Bau and Michal Lapik, they're helping out a lot. But the fact that the language is very tiny means that there's less effort to do when you're doing the translations. And OCaml also has this really good scaling properties, right? Jane Street, just to give you an example, it's a company that builds everything they do in OCaml. Their front ends, OCaml, the back ends, OCaml, ML pipelines, OCaml, command line tools, OCaml, everything is OCaml, right? And they have this massive mono repository where they have helped over the years to make sure that the compilation times are small and that the compiler works in an incremental fashion. So this really scales. If you have 10 OCaml files, ML files, or 10,000, right? You need a compiler that can handle that kind of load without unnecessarily redoing work. And it's built for that, right? It also scales great for scaling the actual code that you're reusing across different parts of a company or a system. Functors are a great way of saying there's a module that needs to be sort of templated over with these inputs, right? And still generate code that is type safe. So it's not really a way of doing meta programming, but it allows you to generate code dynamically that is type safe as well. And on top of that, it does have support for type safe macros. They're not macros as you're used to, like read macros on Lisp 1, right? But they allow you to do pre-processing of your code and embed all the languages even in a way that when they get expanded, they're still type checked. So they have to be type safe. And the compiler itself is written to be extensible, so it's kind of nice to work with it. You have a front end, right? You have a back end of it, and then there's layers to each one of these parts, and there's a connecting sort of membrane in the middle, the typed tree, right? An AST that has already typed, that allows you to communicate between one side and the other. It's actually kind of neat, right? And I personally think that it has a rather elegant syntax. All right, so we've seen why OCaml, then why bring that language to the Erlang VM? I've been working with Erlang for maybe 7 years today. Someone might quote me and say that that's true or not, but I think it's one of the most scalable runtimes for functional languages out there, right? We've had functional languages like Clojure running on the JVM, and the JVM is great, right? That doesn't mean you can love the JVM and hate Java, for example. That's completely fine. But Erlang, I think it does give the JVM a run for its money when it comes to scaling the kind of programs that you run in Erlang, that you write for Erlang, right? It supports massive concurrency and parallelism from the get-go. So the beam is built so that when you write a program and you write it with the concurrency primitives of the language, then it runs on one core or on 1,000 cores, right? Just the same. You don't have to restructure a program entirely to make it scale across different cores. It can even scale across machines if you're into that. It's optimized for low latencies, right? So it's actually built for telecom systems where you need to have sort of a rather long tail of latencies that are very, very short. And it's designed for reliability, right? The entire Erlang and OTP dogma is that you cannot get rid of failures. You need to embrace failure. And once you learn to embrace failure, you can build reliability around that, right? Joe Armstrong's thesis essentially is about that. Is how do we build software, reliable software, in the presence of errors? So all of the supervision patterns that the Erlang VM supports by default, right? You could think of them as a built-in Kubernetes, right? You have Kubernetes that says there's a pod. When it crashes, bring it back up, start everything, just make sure the entire mesh of services works. The Beam already does that. It already did that for you like 10 years ago, 20 years ago. So I think it's a good VM to target, which takes us to one of the last points, right? It's a good compilation target platform. We've seen all the languages, right, targeting before. We have Elixir, which is already a success case, right? Jose Valim has done great work in bootstrapping the language. The community has taken it so far, so forward, right? And there's new languages coming along, like Gleam from Luis Pielfold, Clojure from Juan Facorro, and then LFE from Robert Birding as well. They're all targeting the Beam. They're all bringing all of these different like syntactical level, or rather language level features to a runtime that's already kind of awesome. And lastly, OTP24 RC1 just got out, I think, a couple of hours ago. Yes, confirmation there, good. And that means we have the support for just-in-time work by Lucas Larsson. And that means that all of your programs will run just insanely fast. So it's a really good VM to target. The Erlang VM, the Beam, it's pretty hot these days to target. So that's why I'm choosing the Beam to target OCaml in this instance. So why a sound type system? You know, there's other languages targeting the Beam these days, and they're all pretty good. In fact, we're having another talk about Clojure right now, right? Which means Clojure is now targeting multiple virtual machines. You could pick whichever you want. The Beam, go for Clojure. You want the JVM, go for actual Clojure, right? And they're not type safe. They're not sound. They don't have a type system in the same way. So why a sound type system? From the get-go, it rules out a great large number of errors. So a lot of things that happen accidentally on Erlang and Elixir all the time that you cannot catch when you're sort of building or testing will be rolled out by default. There's a lot of bugs that appear because you don't have types to actually guarantee that a function is called with the right inputs. Hopefully you have a test for that. Hopefully you're exercising that path of code. Hopefully your supervision tree will actually restart that when it crashes, right? And in production it will be okay. But it will still be there, and it's something you have to deal with. Sentry alerts, not fun. I don't want that, right? If we can get rid of that, then great. Second is that a lot of things that can be represented in your program maybe shouldn't be represented, right? So I don't have a practical example right now, but there's a lot of states in which you can get in dynamic languages that a statically typed language can just say, yeah, we don't allow this. So no, you cannot set the password to empty string, for example. Or you cannot, you know, withdraw from a bank account that doesn't have this, this balance. You can put all of these constraints at a type level. Sometimes these constraints will be domain constraints. So you'll sit down and talk to your PO, and they will make sense of what needs to be encoded, and you will figure out how to translate that to the type language, and then bam, you write it as types. Can happen. You can also refactor large code bases much more easily. Sometimes I sit down and I make a change in an Erlang code base or Elixir code base, and I'm wondering, did I remember to test this? Will it be okay? And the reality is that if I don't remember and no one else in the team around me does remember, then we just need to run the software and see what happens, hope for the best. I kind of want to be able to say, well, something changed in the domain, we need to go into this type or record and change it, and just like the compiler guides me through the process. I feel a little dumb sometimes just following the type errors, but by the end of the day, when the compilation is done, then I know that that's not going to be a problem, at least not at the type level. I think I'll try to speed up a little bit, but there's some other things that I think are incredibly important, like the developer experience that a type system can help with. Just think of what TypeScript did for JavaScript. If you're using VS Code these days, most of the things that you get for free when it comes to auto-completion come through the TypeScript inference, the TypeScript engine, right? Type engine. Or for example, what IntelliJ does for Java. I wish we had something like that for the Vim. I really do. And lastly, I don't think typing by convention works very well. Like agreeing that we're going to have abstract types and we're going to be like safe and try to be careful, that just doesn't scale. I'll mess up, you'll mess up, and then we'll end up with a production bug. I don't want to wake you up in the middle of the night saying, hey, you modified this module. What happened there? I don't understand how to fix it. So I think a sound type system can help with all these things. This does not mean that you don't need to write tests, test help. This is just one more tool to build software. Building good software is hard. We need all the tools we can get. This is where I drink water. Yes. So why not write just OCaml, right? Well, OCaml has a runtime that's rather limited these days. It's multi-core OCaml is coming, but right now it's single-threaded. So when you write concurrent programs in OCaml, right, you have to sort of make cooperative scheduling with promises or futures. So you have to be careful to understand how that's going to execute and make sure that your promises are not blocking. If at any point in time you sort of read from a standard input and you didn't use the right function for that, then you're blocking the entire program, period. The community and the libraries, the ecosystems, are incredibly good. They're really strong, but they're also very scarce. There's very few libraries compared to Elixir, for example. They're really good, but they're just less. And same for the community. There's not that many OCaml programmers around, even though they are. We exist. We are real. It's not like when you go to the Elixir Slack and you find 30,000 people just talking about stuff. The volumes, the numbers, the scales are different. All right, so last of this slides, and we get right into what Carmel actually is. Carmel is an OCaml dialect. That means that it has no mutability and no object-oriented system. So it's an OCaml, but it's not all of OCaml. It's changed. It's a reduced set of that, right? It's statically typed. We have algebraic data types. We have tuples, records. We got variants, polymorphic variants, GADTs as well, or GADs. We have full Hindley-Milner type inference, which means you're very unlikely to have to annotate your code. That kind of means type your code, the compiler figures out the types for you, which is pretty nice. We have structurally typed modules. We have functors. We got a very lightweight FFI syntax to talk to Erlang and Elixir. And we will also have soon type-safe macros as well. So this is kind of like a very high-level overview of what you get with the language. So what's the status? Where is Carmel today? A couple of weeks ago, maybe a month ago, we released version 0.1, which means everything is still pretty much of a work in progress, right? Don't hold your breath and don't go rush into your manager saying, hey, can I write everything in Carmel today? No, maybe in a week. We'll see. So I'll do a little breakdown of the language features, the tooling, the standard library, and the documentation and manual, which I think you need to be aware. These are all of the parts that so far we've scoped out are Carmel. Carmel is not just the language, it's the tooling around it. It's the community that we're building. So what's the Carmel language? Oh, I realize the slides are kind of small. Well, the Carmel language, has lists and tuples, and you can see in a little example there, and we'll post a link to the slides, right? Yep. Perfect. So that you can look at the code yourself. It has binary strings, so these are not IO lists in Erlang. Right now, these are binary strings, but they're represented as regular strings in the OCaml syntax. It has arbitrary precision integers, which OCaml doesn't have by default. You have to use external libraries. So all of the math that you're doing for your finance stuff right now, you can do it here, just like you do in Erlang, right? Without having to add any other libraries, and it's on top of that type safe. And it has side effects, so it's not pure. So if you want to print out something, IO.format, you can absolutely do it. It's completely fine. Very pragmatic. It has records and variants, and we see a little example here, right? It has opaque and abstract types, so you can define types for things that you don't want exposed. So the rest of your application just knows there's some type called ID. I don't know what it has inside, but of course some part of your application does know what it's inside. It has type-directed pattern matching with exhaustiveness checks. So if you do a match on some variable, you can say these are all of the possible variants or fields in the record that this input value will ever have. When you change the type, then a compiler will complain, saying, "Hey, you're forgetting this and that over here and there." And the type inference in this example is figuring out that the actual type of that value is of the type action above in the example. It has a really flexible module system, right? You can nest modules inside a file. You can pass modules around. The functors, which are not illustrated here, lets you pass modules as functions of other modules. It gets a little complicated, so we're not going to get too much into that. It supports partial application and currying. So if you're into that, go ahead, do it. Just please don't do point-free programming. Or, please don't. It has tail call optimizations because it runs on the beam, so it's tail optimized, right? And functions support not just named arguments and pattern matching on the headers, but they also have default arguments. So you can have a function that says, this is the argument that I expect, this is the default value, this is the name of the argument, right? And then you can curry and do all the magic you want there, it means that you can build domain-specific languages just by using functions, which is really nice. All right, so the last thing we have about the language, I think this is the last thing, it's zero-cost interrupt. And in this tiny example, we show a module called logger, and the module just has an external definition. An external is a feature of the language to tell the compiler there will be a function at runtime, right, that will be called this, and it has this type, right? And when you compile it, if your module has only externals, the module goes away, and you end up calling the module you expected to call in Erlang. So in this example, we're sort of defining a type-safe way of calling the logger info function without actually adding any overhead to it. But it's type-safe, right? I think it's pretty cool. So when it comes to tooling, right, and I think this is really important, Carmel is right now being distributed as a single binary. It has no external dependencies. This makes it really easy to bootstrap your machine or your project with it. You just download the Carmel binary. You have everything you will ever need right there. Some tools that we're including right now are the code formatter. So you don't have to bother talking to your colleagues about how do you want to format it. No, that's built in. You compile with Carmel compile. You format your code with Carmel FMT. Done. And some things that we're working on right now is a built-in language server. So there's not another thing that you have to download and figure out if it's the right version for the right compiler. No, it comes packed in. You go Carmel LSP, and that starts the server. You're done. We're working on including a documentation generator, right? So you can say Carmel compile, and that will actually compile your documentation as well if you tell it to. And the last thing that we're looking into is including in the compilation binary, like the Carmel tool, the preprocessor, the thing that will let you embed GraphQL syntax inside of an OCaml module, right? And generate type-safe OCaml code from that GraphQL syntax. This is stuff that's already been built. It's already being used in production. I'm not coming up with any of this. The formatter, OCaml format. We borrow that, we vendor that, right? The language server, OCaml LSP, right? It works straight up with a few tweaks here and there, right? Documentation generator, OCaml doc. It works great. So I'm really just repackaging the tooling that works in the OCaml ecosystem, but getting rid of the assumptions they make about the tooling that they use, like Dune, the build system, and whatnot, and making sure that it works seamlessly with the assumptions that we're making in Carmel. For example, that it works with Mix or Rebar, which, by the way, we're working on those plugins right now. I think the Mix one is kind of usable, so if you want to give it a shot, just search for mix_Carmel. I think it's even on HexPM. And the last thing that we're working on is a VS Code extension. So there's a lot of work being done in the tooling section and not just on the compiler. So I really want this language to be approachable so that you download the thing and it's like, oh, I can start building projects now. I don't have to figure all these other things out. The next thing is the standard library. And that's also a huge topic. Right now, we have a standard library that's sketched and modeled after the Erlang standard library. So you will find modules like ETS, right? But what we're really looking forward to do is to build a library, right, standard library that is batteries included, that is inspired by languages like Rust or Golang, that they have most of the packages you need to be up and running. We're focusing on reusing everything that we can reuse from the Elixir and Erlang ecosystems, all the high quality libraries we're trying to get from that, and making sure that it's type safe as well. So some of the things you'll find in the standard library are core modules, like for booleans and strings and binaries and whatnot, but also collections, file system utilities, a net module that I expect will be reusing stuff like cowboy or gun under the hood, right? So you don't have to figure out which one is the best HTTP library. You just use the one that comes with the platform, which I think is the best. You can challenge me there. Please do. And other things like typed OTP, for example. Lastly, we have the Carmel manual. And the manual is another just massive piece of the ecosystem to figure out, which is how do we get people introduced to the language? How do you get started? What's the installation process? How do we write something that will let you get on board and do your things, the tasks that you need to do, fast and quick and easy, right? We have guides right now for calling Erlang and Elixir libraries from Carmel. We need to do the opposite as well. We need to figure out the references, right, to language features, how to compare it with Erlang and Elixir, so it's easy for you to say, okay, I have this code in Elixir, how do I translate that to Carmel in a way that it's safe but still kind of intuitive? We need to do all this work. So, almost done here. The future of Carmel, right? I would like, by the end of this year, to be able to write the core of a Phoenix app in Carmel without too much hassle. You said like mix Carmel and just drop a couple of ML modules there down your tree, and it kind of works. Just call it back and forth, it's fine. There's so much work to be done all over the board. We're still scoping what is it that the standard library will be like. There's open issues in the repo, so get involved there. We went from 0 to up to 12 supporters on GitHub sponsors these days, and all of that money is going straight into helping Carmel succeed, right? The first goal is underway. We're like, I don't know, 35% there. So if you have a spare dollar, go ahead. We can use it for the domain, for getting a designer and doing a cool logo for stuff like that. And I think the most important part of the future is that we're building a community. Very slowly, we're building a community. There's 2 strong contributors that we've been speaking with on Discord every other day, and we're going to start meeting every month to set the direction of Carmel, to figure out what governance will be like in the future, and just making sure that this is something that's built to last. Just like the Beam, where you write software once and it kind of runs forever. So that's all I got for you. Thank you so much. My name was Leandro, or is Leandro, and there's a couple of links here that you can use. Yeah, please.
Yes, thank you very much, Leandro.
I guess we need this.
Yeah, no, please stay. I'll do some questions for you.
Oh yeah, okay, sure.
Yeah, or I will say that we'll put all the links and stuff you had. We'll put it on the MeetUp page, and we'll put it. And I'll also put everything under the once we publish like the YouTube video. We'll put it under there also, so people can find it.
That sounds perfect. Yes.
Yes, so you can build your community. That sounds really cool. Yeah, our community. Yeah, sounds really cool. I had one question. How come you got into functional programming?
That's a good question. I actually was asked that recently, and so I had been doing PHP and Ruby for some time, ages ago. And one of the things I loved about Ruby, and I hate that about PHP, was that in Ruby you have this tendency of grabbing collections of things and building these pipelines for transforming data. You have this array and the dot map, and then you pass in this block and do this thing and so on. And at some point, right, I realized that my problems in general were always the same. Build an API, move some JSON data to a database and out and back into the web. And I felt like I needed bigger problems. And I figured no one's going to hire me to solve bigger problems if at least I don't know the tools used to solve bigger problems. WhatsApp was around that time booming, saying like we have, I don't know, 25, 30 engineers and like 1 billion users. What's WhatsApp built in? Erlang. Maybe I'll teach myself Erlang. And I found that the connection between building pipelines that transform data and Erlang, even though syntactically kind of awkward, is still there conceptually. So I just jumped into FB after that.
Yeah. So that's your way into functional programming.
Yeah, I needed bigger problems.
Thank you very much again.
Thank you so much for having me.
Yes.
Yes, I guess I will walk away.
Yes, I will push you out here.
Yeah. So I crawl now?
Yeah. Now, welcome up on stage next speaker, presenter, David Vujic, and his presentation, ClojureScript React with a Hiccup. Ooh. Welcome, David.
Thanks.
Yes, and now we'll switch the HDMI connector.
Okay. Should I stand here?
Yeah, that would be good.
Great.
Put it in here, and voila.
Perfect. Just need some power, I think.
Yep.
Okay. I've got to prepare if I forget what I'm going to speak about.
Yes.
I think I need
That's
some
good.
water too. Yeah.
Yes.
Perfect.
Gonna see if David's laptop works. Oh,
Yeah, hopefully.
remember your password.
Yeah.
It's always a good start.
Okay. Can you see my screen? Perfect. Okay, should I begin? Fine. Okay, welcome to this session about ClojureScript and more specific, like how to develop React components using a style or a syntax called Hiccup. My name is David, and I have coded Clojure and ClojureScript for about 1 year. I joined a team that develops web apps and services using this platform. Thanks. And before that, I have coded a lot of JavaScript, Node.js, Python, and also I've been very much in the C# and .NET world, so coding like ASP.NET and Episerver and things like that. But I've coded Clojure and ClojureScript for a year, and what I want to do tonight is to share what I have learned basically during my first year as a Clojure software developer. Yeah. And I want to begin with just a quick, not an intro, but I want to highlight some things about the Clojure language itself, and things that we use a lot when we write ClojureScript apps. And one thing is that we use vectors, and a vector it's an array, and in Clojure it's called vector. And each item is separated. We don't use commas and things like that. It's separated with space. Another thing that we use frequently is maps. So it's something that you store keys and values. So it's sort of similar to what you have in JavaScript, like object literals or even JSON, or dictionaries in Python. We also have something called keywords, that we use a lot in Clojure and ClojureScript. And keywords are used, for instance, if you look at the map, you see that I have used something called keyword for the key position of it. So we can use strings, but keywords has some additional functionality that is really nice to use in Clojure. And of course, we have functions. And since Clojure is a part of the Lisp family, so basically what we do is we write lists. We wrap everything in parentheses. Okay, so vectors, keywords, and maps. This is something that we use if you want to develop a web app using Clojure entirely. So what you can do is to write the HTML markup using Clojure data structures. And what you see here is basically will be rendered as a HTML div tag. So an element is written using the Clojure vector, and the element type is defined by using a keyword. And it's this style of writing HTML markup that is called Hiccup, or syntax. So here's another example. Here's a link or an anchor tag. And what I've used here is, links often need an URL or additional attributes. And attributes are defined using Clojure maps. So we have a keyword defining what the attribute name is, and the value is the value of the attribute. So I can have one or more attributes appended to my element. So if I would like to put this link within a div tag, so this is how I could do it. I sort of nest the vectors, or nest the arrays. And if I would write the same code in React JSX or plain HTML, I would probably do something like this. So this is the equivalent of how you would do it in pure HTML. Okay. If I put this div tag within a function, well, then I have actually created a React component or a component. So placing Hiccup markup in a function will create a React component. And in this example, I have an input parameter that kind of so you can reuse the URL. Great. So ClojureScript is really what we do when we write web apps in ClojureScript. Is we use the Clojure language, and we have something that compiles it to JavaScript, and then you can run it in a browser. So essentially, ClojureScript is a compiler. So you write your things in Clojure, compile it, and it's the output is JavaScript. So, and you don't actually press some compile or build button. The compilation occurs all the time as you type. But ClojureScript only cares about JavaScript. So if we want to build something based on React, we need some help. We need to help the compiler a bit. So I'm going to add a library called Reagent. And Reagent is a sort of a tool or a library that kind of wraps React. So it makes it possible to write your React components using Clojure, and it will be compiled to JavaScript that can run in a browser. Okay. So this is the part I'm a bit extra nervous about, because I'm going to try to live code some parts. Okay, so I have my Hello World example site running here. Let me double check that it's so it seems to work. So what do we have here? I have prepared with some example code. And what we see here to the right at this side, you see my editor, and over here you have a web browser. Okay. And what you see here is some code, or some functions that actually are React components. So if I go from the top here, I have something called theme toggle field. I'll come back to what it actually does in a moment, but it returns an input field, or more like it returns a checkbox. So, and it has some CSS classes to it and things like that. And I have another component that renders out or returns a HTML label. And it sort of is connected to this checkbox because it's using the same ID. Okay. Over here, I have some sort of a container component, like kind of wrapping or adding sub-components to it. So I'm adding this theme toggle field, I have a div tag, and I'm adding this other component over here. These two functions are a little bit different because this one is actually a sort of a helper function. I'll come back to this just in a moment. Over here is the entry point for my web page. This is where everything starts. So I'm using this reagent library, and I'm telling it to render something. I'm telling it to render my container component. So if I could actually ask it to render just a div, and the output will be different, like this. And the second argument here is that I want to tell reagent where to actually put my components. So if we have a look at this function called main element, so this is where I'm starting to use some sort of JavaScript interop, because I work in a Clojure environment, but I have full access to the JavaScript APIs to access browser things. So what I'm doing here is I'm using the global document object and calling this getElementById function with an ID. So, and what I can do, I can actually try to run it in my editor. It looks like it actually returns something. So if I would by accident misspell the ID, then I would get something wrong with it. Let's do something like this. And I can also inspect what kind of element is this. So I can actually continue to try to extract the wrong key combination. Extract the ID of that element. So it seems that I have the right element. What about the tag name? Oh, it's called main something. So by doing this, I can try to experiment to understand what is returned from this function. And so where is this element named ID? Well, I have added in my example site an HTML template. This one will be used in combination with my Clojure code. So, and if we have a look at it, I have added some fancy fonts and a couple of CSS files. So I can use like CSS and whatever I'm used to. I don't have to relearn how to use CSS and things like that. So I can use what I already know. And here is this root element where I want to put all my React components. And as we evaluated, it was an element called main. And I have two script tags too, and this row 13 is actually the code that is compiled, my Clojure code that is compiled to JavaScript. And on this row, this is actually where I kind of trigger my main function in my Clojure app. If I go back to this app, CLJS. So what makes this possible is that I have this funny looking character here. It's some sort of metadata to my function. And I'm telling the ClojureScript compiler to treat this function as an entry point. Because when we package this and send it to a production or to the internet, all JavaScript will be packed and minified, and all the function names will have very shortened names, except for this one, because this will always be called main, because I've asked the compiler to keep it like that. Okay. So let's go back to this page component. So have added a div tag and put some component within it. And you can see that here I've added an attribute. And since I only have one attribute, and I think it's a little bit verbose to have this style, I can shorten this a bit and skip this this map. So this is also a way I can write my element and attaching a div tag to it. I think I can do the same thing with this input. This checkbox. I can append the class name directly here. Something like this, and then I can get rid of this row here. Oh, sorry. Let's do like that, something like that. So this is the same idea, but personally I think this is a little bit more readable. So I'm going to use the same idea for the label on my other component. Something like this. And I think by doing that, my kind of component will become a one-liner instead, and I like those things. So this is the sort of the same, but a little bit shorter. Okay. This is fine and all, but you know my page is blank. I would like to have some sort of something to read or some text or something. So what I want to do is I want to add a component that kind of outputs some sort of greeting text or something. So I'm going to start by creating a function that will become a component. And that one, I think I'm going to use like a header. Something like this. Oh, I have done something terribly wrong. There. Good. But nobody is using my component here, so I'm going to put it just after that toggle label, like this. Nice. So I have my web page that tells everyone good evening, and but it's still kind of boring. So perhaps you have noticed this funny looking icon here. I think it's a sun. So I'm going to try to press that one. So it looks like it's some sort of a desktop or theme switcher. So I want to kind of do something cool with that. So the way this works is it's because of these two components, the input checkbox and the label, in combination with my CSS files. Oh, didn't I open it? I'm going to just... this is the one. So I actually found this on the internet, on this blog. So thank you, Alexander, for this. I was looking for a way to make a switch, like dark theme, light theme switch that is pure CSS without any code, JavaScript and things like that. So I found this one. Okay. But this is kind of disconnected to... I have no control. I don't know which theme is selected. So I'm going to try to keep track on what I have selected, which theme is currently the active one. And I'm going to do that by introducing another library that is very commonly used together with Reagent. And that is a library called Reframe. And Reframe helps you keep track of state, basically, because Reagent is about rendering like HTML and creating components that you can reuse. And so far my components they don't care about any state or anything like that. So reframe will is sort of will create like an in-memory database for you. So it's like a data that is centralized that code can interact with. And the way reframe works is that you send events to it. You want something to change, and you can also subscribe to changes in a database. So I'm going to include another code, a code that I have prepared with too. Hello.events. We can have a look at that one too. So this is how you can define an event using this library called reframe. And what I was looking for is this event with this name, toggle theme. So what happens when you kind of trigger the event, it will store the active theme. And it actually will have it basically what is behind the scenes. It's just a checkbox. So we will see if the checkbox is checked or unchecked. So that way we can decide if it's a light theme or dark theme. So let's go back to the app here. And I'm thinking about adding some functionality to our checkbox, something like this. On change. And what I want to do is to trigger a function. I will name it toggle change. Toggle theme, sorry. So let's add it over here. So and this function will get the HTML, an HTML event. So it's an object called event. And what I want to do with that one is to extract the oh yeah, now I remember. I want to trigger my reframe event, which is called dispatch in reframe. And I want to trigger that toggle theme. And I want to pass in if the checkbox is checked or if it's unchecked. And I'm going to navigate through my event object. So, and in JavaScript, you browse you navigate to the target, which is the actual element, and if it's checked or not. Something like this. Let's try it out. So every time I click this, an event is triggered. But I have no idea if it works or if it doesn't work. So how can I find this out? I have made some preparations over here. We'll uncomment some code here. So what I can do is I can actually browse the state of my current database from my editor. So it looks like the active theme is dark. So if I kind of switch it to light theme and run this function again, the active theme is light. If I switch back, it's dark. So something seems to happen when I press that icon over here. Good. So this is fine. I have something that keeps track of the current theme that is active. Now I would like something to happen when something else to happen besides the switching theme. I would like to change this greeting to something else. And this can be done by listening to or subscribing to changes of that reframe database. So I'm going to include another, sorry, not a library, but another namespace that I have written. Let's have a look at this one too. There it is. And this is how you can define subscriptions in reframe. So what I'm looking for is this one. So I have a subscription named light theme ? And in Clojure, question marks is a convention for booleans. So this will return true or false. And what this does behind the scenes, it kind of looks in my state database and looks for a path in that database. In this case, it's theme and active and the value of that node. So I want to use this light theme subscription. So I'm going to go back to my app here. And what I'm thinking about is doing something like this. So if it is light theme, I want to write something different than good evening. So perhaps good morning. Otherwise, I want to print out good evening. And since I've changed my interface to my function here, I have to go to this greeting where I kind of use this function. So what I want to do here is to subscribe to this. I want to subscribe to this light theme subscription. Let's try it out. Whoa, it works. Whew. So what happens here is that I'm passing this result of this subscription to my greeting function, and the greeting function does an if and else and displays different things based on that. And if you remember, I went down to my secret code over here to like print out the state of the database. But I can also evaluate the state of my current subscription. So the light theme returned false, which seems to be correct. So if I change the theme to be a light theme, it's true. So I can very quickly evaluate. Oops, I did something wrong here, right? How my database looks and what will be the output of these subscriptions. So what's kind of I don't really like is this weird syntax, the @ sign and things like that. So I'm thinking about I can make this a bit shorter. So I have added a shorthand for it, which is very common if you use reframe. So instead of having this @ sign, I will kind of try to shorten this out a bit. So let's give it a try. So it seems to work fine. Nice. Okay, so what is going on here really? What happens? You've seen me like change some text and the page reloads and evaluating code and things like that. So what happens here? If I go back to like changing some text or something in my page like that, I'm going to add a dot and hit save. Do you see that? Did you see the little icon at the bottom there? So that's my web server kind of refreshing the page. So this is hot reloading. So it's quite common in JavaScript and other languages too. So we have that. And what happens when I kind of press the buttons here? I can actually go here, and I'm going to add a comment section, which is a way to have a safe environment for experimenting with live code. So what I can do, I can actually force executing this my events too. So I've told my database that it's light theme, so my text changed to good morning. Now I have returned it back. So what happens here is when I change my database, so it's not my code that is reloading, but in this case it's React that notices that my component has changed, or the parameters to that one has changed, so it will re-render this specific component. It's like, you know, the virtual DOM and things like that. So that is in the React world. I'm just triggering an event and changing something that has to do with that component. And finally, the thing I've done, you saw me kind of evaluating the DOM and things like that, or even evaluating the events, or having a look at the database like this. I'm having this secret key combination. So this is my editor that is online with my web page, basically, or with a browser. So I have a REPL that kind of runs, and it's connected to what happens in the browser. So it's a communication between the browser and the REPL, which is a server, actually, that kind of does this magic. And what I can do, I can also, if I open the inspector in my browser, I can do things like this. And run this. So I don't know if you see it, but it kind of printed out hello world. So I'm like connected to my browser. So it's back and forth. So I can browse the data, the in-memory data. I can trigger events, and I can like manipulate even the DOM if I would like to do that. And I think this combination of hot reloading, virtual DOM from the React world, and this interactive REPL, I would call this interactive web development. And I think it's very powerful because you have sort of control and flow over during your development. Okay. And I think this is what I have. Thank you for listening.
Thank you. I will sneak by you here.
Yes.
Thank you very much, David.
Thank you.
Very interesting and very brave that you did live coding. Yes, we had two guys before actually live coding. One was a Haskell guy, and the second one was a Clojure guy, actually live coding.
James.
So, yes, yeah. James, he had his live coding, and he also seemed pretty confident to do it.
Yeah.
Thank you very much. Have you done any functional programming prior to Clojure?
I don't know if it counts, but I've coded a lot of JavaScript and try to code it functional. And even when I was mainly coding C#, kind of had a functional mindset, even though it's very much object orientation there in C#. So.
Okay.
So, but this is the first language that is like pure functional and immutable and cool things like that.
Was it easy or hard to learn?
It was for me. It was very difficult. I was like I have a blog post called "The 12 Stages of Learning Clojure." I can post it later. That kind of explains my journey during this year. So it was difficult, the syntax to actually understand, but when every pieces come together, You actually find out the power of the the powerful language that you actually use. So
Yep.
it has been a journey, but also very fun to learn.
Yep. Thanks again.
Thanks.
Big applause. Now, let's see. We're gonna have Max Nordlund up. Yes, I'm gonna see if I can get my presentation going again, and if it wants to connect to the screen. Yay. So, second Func Prog Sweden. It's you, on stage, on picture.
Yeah,
Yes, warm welcome, Max.
thank you.
Yes, and you're going to give us a speech into JavaScript.
Yes, exactly. So for all you functional programmers out there, JavaScript is not dangerous, I promise. And for all you JavaScript programmers out there, function programming is fun.
Woo! Thank you.
Yeah. Or I hope at least.
Yeah.
Okay.
Ooh, you're on.
Yeah, let's see. Better?
Yep.
Yeah, hooray. So, monads in JavaScript. I like silly animations and puns. So it's going to be monads in JavaScript with silly animations and puns. Like the talk itself. Okay. Anyway. This is me. I'm a backend developer at Kivra. There's my LinkedIn and my Twitter, if anyone wants to get in touch afterwards. Kivra is mostly using Erlang, but today I'm going to talk about JavaScript. So yeah. Let's talk first about a fine quote I found on the internet. And since I found it on the internet, it must be true. People are laughing in the background, by the way. That's good. Jag vill visa mina... I want my presentationsanteckningar. Okay. Once one understands what a monad is, one loses the ability to explain it to others. Yeah. I'm gonna break this curse tonight. Oh yeah. And if I don't, then I'm also cursed. Anyway, monads are not too dangerous, I promise. But they are kind of confusing. And that's because they're so broad. And I think if you make it like not as broad as the full monad, like the full monadic definition, it might be easier to understand. And that's why we're going to talk about promises that are, surprise, surprise, monads. Okay, so what's the plan? The plan is, what is a monad? What about JavaScript? Promises and list with a large L, because we're going to talk about monads, and these are two examples of monads. A surprise, because I love surprises. We're going to talk a bit about do notation and how async await in JavaScript, how that is an implementation of do notation, if you want to say it like that. And then finally, questions. Yeah. Okay, let's get started. What is a monad? Yeah, what even is a monad? I'm going to start with a formal definition, because monads are from category theory. If you don't get it, don't sweat it. It's fine. But I do want to, say something about the formal definition, so you know that this has a solid ground. Okay. In the end, though, it's a set of functions, and these sets of functions needs to obey a set of laws. You can think of it as an interface in Java or type class. It's actually a type class in Haskell, or a protocol in Elixir, or so on and so forth. The first function is called unit, pure, or return, usually called return in the monad type class in Haskell, but it's also sometimes called unit or pure. It takes a value and then puts it inside, a monad. So in the promise monad, you would put it inside the promise. In the list monad, you put it inside the list, so on and so forth, right? In the maybe monad, you put it inside. It's not quite inside because monads can represent so many different things, but it's like, think of monads as a box and it gets you halfway there. Next function, map bind, also that's a fun looking operator, or then, okay? And for Haskell out there, you recognize bind because that's the monad definition. Most people probably recognize map from array and the list. And then as in the promise then method, because that's actually bind and other stuff as well. And what that does is it takes a function and a monad, and it applies the function on the stuff inside the monad, and thus produces a new monad. There's also some type stuff that we're going to talk about, but that's the general gist of it anyway. And then these are the ones as well, join, lift, and fail. These are not actually part of the category definition of a monad, but they're basically always there, especially fail. That's just pragmatic. You know, Haskell is also pragmatic. If you want to know a secret, the stuff underneath Haskell called Husk is not actually a proper category theory. Nobody heard me. Nobody's heard me say that. Anyway. Okay. Let's talk about laws. We have left identity, right identity, and associativity. And what do I mean by that? Well, you can define these using bind and return above and join. But it's actually an easier way to see it if you use something called the Klein-Still composition operator. It's gonna let me show the Haskell definition of that one. It looks like this. It takes a function from A to monad B, a function B to monad C, and an A, and then turns it into monad C. So you can see how it like connects the two functions, the first two functions, then takes the value, pipes it through the function, and returns a monad C. That's also the definition if you want to write it using do notation, by the way. I'm not going to go into why that works, but just see it as a way of function composition, like the dot operator or the ball operator. And by doing that, you can see the identities like so. And here you can see what I mean about left identity and right identity. If you just put something inside a monad, like do no transformation, just put it inside, you can put it on either side of the Klein-Still composition operator, and you get the same stuff back. Right? If you apply the identity function, you can do that in any order and nothing happens. Okay? And then associativity, it means that you can combine this function in any order if you combine more than two, like the standard operator does. And that might be a bit confusing to see how that works. So I brought some visual aid. Here we have those three. Let's take the first two and combine them, like so. And now you have fg, right? Which is a function that takes some value, pipes it through f, pipes it through g, then spits something out. And then we combine these two. And suddenly we have one function. Okay? Lovely. Okay. Maybe I should ask for questions. Are there any burning questions? No burning questions. Okay. Let's continue. What about JavaScript? You promised us JavaScript. And this is a pun for those that doesn't get it. Just want to point that out. Yeah. Anyway. Okay. What about JavaScript? For those that doesn't know, I'm going to do a brief introduction to what a JavaScript language is. And then we're going to talk about promises and stuff. So JavaScript is a dynamically weakly typed memory managed language. The complete opposite of Carmel. Yeah. Okay, so dynamically typed, what does that mean? It means that the values themselves carry the type, or stuff is happening. Whoops. Okay. My animations are probably off. Anyway, you're going to get a sneak peek. So dynamic means that values carry the types, not the variables. That's true also for Clojure, it's true for Erlang, or the entire beam actually. That's one thing. Weak, this is not a common property of many languages, but it means that stuff is automatically converted. And this is why you can have the string 1 plus the number 1 becomes the string 11. You know, the classic stuff that people get confused in JavaScript. If you do a number plus null, what do you get? The same number, because null it's turned into 0. Because it's unit or bottom of integers, and null is the unit or bottom of all objects. Anyway. Okay. Anyway, so that's weakly typed. Managed memory, what does that mean? It means that stuff gets garbage collected, right? We don't have that sort of issues in JavaScript, which is very nice. And finally, or like additionally, it's object-oriented. This gives us duck typing. If it walks like a duck and talks like a duck, it's probably a cow, but it's okay. We can speak to it like a duck. This is how you can implement an interface, right? You don't need type classes. You don't need to say implement interface. You just implement it and it kind of works. Okay. And this is how you can actually implement Denable, which means that you can play along in the Promise ecosystem, which is kind of cool. Okay. But what about monads in JavaScript? Yeah. Okay, there are at least two. I'm going to talk about two anyway. There are probably more, but the two easiest ones are, of course, promises, as I was talking about. And here are the definitions. And arrays. And promises, okay, let's step back a bit. As I said, it's a weakly typed and a dynamically typed. It also means that it's very easy to do polymorphic code. So instead of having multiple named functions that you explicitly call to use the correct type, you can just use one name and then like pattern match or like check inside what you want to do. And this is how promises are implemented. So even though there are 3 different functions, and also here I'm showing you one more, the star operator thingy. It's from applicative, if you like functors and applicative functors. It's the, I don't know what the name is. I think it's apply, maybe. Anyway, all of those are done. So even though they have different signatures in Haskell, we can just forget about that because in JavaScript, it's okay. You can just do it polymorphically like this. And here you can also see that if you want to put something inside a promise, you use promise.resolve, which gives you back already resolved promise for that value. If you actually use the promises, you know what I'm talking about. Fail becomes react. Seems reasonable. And then let's talk about arrays or lists. So when you do, like when you implement monads for lists, it becomes, like they talk about a bunch of stuff and it's really, I don't know, flummigt in Swedish. In reality though, they use flat map. That's it. So you map a function, it returns not a single value, but it returns a list of values, and it just splats it into the big one. This means that if you return the empty list, you effectively implement filter, you remove stuff. If you return the item with just one item inside, it's a plain old map. And if you return multiple items, you can suddenly expand something. And this is where the real power in the list monad comes from. You can have 0 to many results, which is pretty cool. You can do that for auto-completion, for example. You can splice up and get more, or you can get nothing, right? Return pure array.from, takes the stuff here, turns it into array. Very good. It could also be array.of. I'm not sure. It's a taste difference, I guess. I don't know. But then fail. I think this is interesting. Fail is just a new array. The empty array is representing fail. So even though we talk about failures, we usually talk about exceptions, and we talk about errors. Failure can be many things. And one way of seeing a failure is no result, right? the lack of a result. And in the list monad, that means the empty list. This is akin to nothing in the maybe monad or null in optional. If you're using Rust, for example, you have optional. If you're using Java, you have optional. They have null or nothing, and then you have something, right? Something called just a nothing or something, and I think it's nil. Sorry? None. Thank you. None in Rust, right? Yeah, maybe. Anyway. Okay. But you're probably really bored by now. Also silly animations. So let's switch it up. Let's do some live coding. Yeah! Now hopefully I can switch to, sorry, maybe I do need to do this. Like that. Nej. Nej. Åh nej, nu har jag flyttat på den. Nej. Ah. Syns. Är det rätt nu? Oh, perfect. Lovely. Oh, this is going to be interesting because like the screen is actually not here on my laptop, but on TV further down. So I'm have to squint my eyes, but it's going to be nice. Okay, let's see. This is actually really hard. Okay, I think I'm on the right one. Maybe I can actually. System is telling out. Maybe I can double the screen instead so I can actually see something. Ja, precis här. Uppställning. Skärmdubblering. Där. And okay, now. Can you see the code? Lovely. Let's make it bigger. Oh, it's so sweet. It's so sweet looking. Look at this. Okay. So I wanted to implement something for the list monad. And it turns out it's really hard to find a good example. So I implemented Fibonacci using the list monad. And it's really, really awkward. It's really awkward, but it works. And it's actually list monad. So as you probably know, Fibonacci, if you want to calculate it, you just add the previous two numbers to it, right? It becomes bigger and bigger. Okay? And that's easy to do in a while loop. You can, if you have mutable state, you can do that. You can do recursion, stuff like that. In my case, I wanted to use flat map. So how do you do it then? Well, the classical definition, the easy definition is up here, the recursive one. It looks just like this. n-1, n-2, add them together, do recursion, let the language stack handle remembering stuff. It's fine. This breaks after 10,000 steps because then you run out of stack, but it's okay. Fib, on the other hand, you can use a hidden function. In my case, I just put an underscore. And you start with the two first numbers and you flat map. And that means that the first one will become whatever this one returns, right? And then the other one. And then it will get flattened. So even if they return multiple steps underneath, it's just going to be bigger and bigger, right? And we do the same thing inside fib. We also use a flat map. And what we do is that we pick out the previous number here, this hacky code. We put the previous number and the next number, a plus b, and then we flat map again, which expands it one more step, like that. And of course, in order to not recurse in infinity, we have to have, if we're actually on the first one, we ignore it. And this just stops after 10 iterations. So let's see it in action. Sorry, this button maybe. Hallå, härligt. Node. Oops. Sync. Wait. I need top level await. There we go. Yeah, experimental stuff. This is cool. Okay. So, since I'm using this new style export import syntax and stuff, you need to import it using a promise. Haha! See what I did there? Haha. Anyway. Fib. Okay. Wait. I want this module. Fibonacci. Like that. Fibonacci. Punkt. Fib. Yeah. Punkt. Fib. And if you do that, you get the Fibonacci sequence like this. Yeah, and also if you do Fibonacci and you do 10. Oh yeah, that's the 1, 2, 3, 4, 5, 6, 7 steps. Sorry, 6 steps. You get the same as 8 up here. Yeah. Anyway, this is an example of the list monad. It's a bit awkward, I guess. So let's talk about something that's less awkward. Finally getting to the promises. Yeah. Here's promises. Oh my God, it's going to be so lovely. So I'm importing some stuff from the Node standard library. Readline to be able to get input. Util allows me to dump some stuff to stand error. And I also need to import process. For those that use Node and know that process is injected into the global scope in models, it's not in new style, ESM style modules. You have to import it. They try to clean up the global scope, which is kind of nice. Anyway, let's hide that. Speaking of util, util also has something called promisify. And what that does is it takes a function, a node-style function that expects a callback, and turns it into something that returns a promise instead. It also does some other special handling, which is very nice, but that's good. So that means that if you're in the Node ecosystem and you're writing Node code, and you get something that expects a callback, you can just turn it into something that expects a promise instead. And since you need to, I also bind it to so that this is set to the correct value. This is just function bind, the built-in one. So I promisify write, I bind it to standard out, I promise write again, bind it to stand r. This allows me to write and write to stand r using promises instead of using callbacks. Here we have inspect, that inspects some stuff, writes it, looks like this. Note that this just returns here. It doesn't wait, right? It doesn't actually wait for the promise before it returns. It's not an async function. Because inside a promise, inside the promise world, inside a monad world, you can return both plain values and monads. And they get absorbed by bind or map or then whatever we want to call it. So you can have a plain old function returning a promise here, and this will still work. Pretty sweet. Here's some readline stuff that allows me to actually read, input in Python. And here's another example. If you want to interface with something that has a non-standard interface, in this instance, readline question also receives a callback. But instead of using the normal callback convention in Node of error value, it just gives the value, right? So we can't use promisify directly here. Actually, you can, but just ignore that for now. So instead, we need to construct it ourselves. And so the promise constructor, it is not return, unit, or pure. That's promise.resolve. This is written to be used in the real world, right? This is written because when you actually want to interface with the outside world, you sometimes need to like construct promises manually. And what it does, it takes a function, this function here, that in turn receives two functions, a resolve and a reject. And these will resolve or reject the promise outside here, the newly constructed promise. A lot of words, but what it means is that you get a like an event hook handler thingy where you can like manipulate the state of the promise outside. So we just do resolve here with the answer. Everything is good. We ignore reject because we can't handle errors anyway, so whatever. If this blows up, it blows up. Oh well. But question doesn't, like the API for question doesn't give us any errors. So we can't even show you that. Okay. So I'm going to have two different sets of functions here that are literally the same. One is going to use async await, and one is going to use more of a classic style. So let's look at the nice modern one. And this also ties into do notation. So in Haskell, for those that know, you can do this pipe operator thingy. I don't know, looks like this. My monad value looks like this. And in JavaScript, that's actually await. Await has that. That's the syntax for the new notation. So async await is do. It is the same. Oh my God. I'm so happy. Okay. When I started writing code with promises, there were no async await. You had to do it by hand. It was still fun. It was still nice, but this makes it so much nicer. So here you can just dump some stuff to stand error, and this will wait until it's actually been written before it continues. Await, right? Pick out some stuff from the argui. If it's undefined, we can await here. This is interesting. If this is not undefined, this synchronously goes continuous. Like the code continues to skips this step. But if it is undefined, it actually blocks or waits. It doesn't actually block because of copyright in multithreading. Inside JavaScript, you can have multiple handlers like scheduled. But here you can see that even though we have a synchronous flow and an asynchronous flow, we can still write it like in a synchronous, way. We just sprinkle some awaits here and there, and that makes the code really readable and nice. We're gonna look later down there in the classic one how this is done if you do it without that. Right, hello, name, new line, return 0, everything is good. Okay, let's look at how this is like desugared, kinda, / how you would write this by hand. So if you do it by hand, you get then. And then takes two functions. We're only gonna use one. The first function is the success case. The second function is the failure case. You can also use catch if you want to make it easier to read. Anyway, so then you can read it as do this and then, right? Call this function that I gave you, this piece of code here. And you can see it does the same thing, but here, what is name now? A promise. It's not a value, it's a promise for a value, right? Okay? This means that we can't read here. We don't even know what the name is going to be like. It's just a promise that in the future, eventually, maybe not, who knows, it will become a name. However, a promise is still a value. It's like actually an object in JavaScript, right? Which means that it's a first-class citizen. We can send it around. We can do stuff. Just like functions are first-class citizens and you can implement map. So we need to handle that. Of course, it can be just a string as well. And since it can be both a string and a promise, we need to consolidate those. And to do that, we use return. You'd be like, what? What is this dark magic? It's actually, I lied. Resolve is not just return, it's also join. Yeah, gotta love this. Anyway, so promise.resolve can receive either a plain value or a promise. And if it is a promise, it will actually wait for that promise and unwrap it. But if it's a plain value, it will just pack it up into a promise. And this means that afterward here, in this then here, name will always be a string, no matter if this was a promise for a string or a plain string from the get-go. This is really, really powerful. You get something, throw it into promise.resolve, you know you have a promise, everything is good. It also means that if you want to do stuff in parallel, just map promise.resolve on everything. Now we get individual promises. And if you now run something on each of those will run in parallel. Because again, monads and promises are first-class values. You can manipulate them, you can use stuff. There's something called promise.all that takes a list of promises, awaits all of them, okay, that's the name, all, and then it calls and then it returns a function for the entire, like a list of all the resolved values. If any one of these reacts, any of those explodes, it skips calling your function and it continues to bubble, right? Really, really powerful stuff. You also promise.raise. These are kinda like any all in most languages. In JavaScript, they're called some and every on array. Array.every, array.from, some. Anyway, then you do some stuff, you write some stuff, blah, 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 all the way here. But wait, there's more. I need to return here. I need to return here, 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 and here. At every single point, I always have to make sure to return the inner promise, or else the outside, the promise machinery, don't even know that there's a promise inside. If you don't do that, you get a rogue promise. Very bad, no good. You actually get warnings and future versions of Node will crash. Unhandled promise without a catch handler. Don't. Always have a catch handler or just return the promise to keep inside the promise chain. This is what makes this right here and this right here happen in order, right? So return all the way down. You can also see that I've been nesting these functions, this then handler functions, all the way down. And this is because if you want to access something in the outer scope, right, you need to have a closure, as in function closure, in order to access those. And this is actually what the above the sugars do. You get all of this nesting, except this is nice to read because it's just plain old stuff, like that's easy, this not so much. Real promise code usually do something like this. Then, like this, then, and then you do then, like you don't nest this much usually. And instead, if you need a value, you return it and like push it forward to the next function, and you do pipelining and stuff. If you do this by hand. This is how we used to write it before async await. And some of you might remember. Okay. I'm actually going to show you one more thing, or two more things. First, this is, oh yeah, here's an example. I import the module. I destructure the module to classic and modern. Do some arg parsing, and just check like this, but you know. Decide if we're going to use the classic or modern version. Again, I just return a promise there, and it's fine. And if something goes bad, I do a catch. I handle it, I do something, blah, 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 and then done. And here's another thing. Since I caught the error here, this then will always be run. Right? Because I swallowed the error, I handled the error. If there were no error, this is this function here doesn't get called, just like a normal try catch, right, in your favorite language. Okay. And now I'm going to show you something even more fun. Go. I don't actually code Go. Oh, okay, I did code Go 7 years ago, something like that. But I wanted to show you that you can find monads pretty much everywhere. And so Go has this feature of deferred to do like finally, try finally in many other languages. What it does is it says that before you return from this function independently if you are panicking from an exception or if you actually return and call this function. And then ignore if that panics, kind of. There's a very common in this ecosystem to return the thing which might be nil and R which might be nil. So you return explicitly the value or the error, like a result in Rust. You check it and then you do an early return. You abort. Okay? This is like the bog standard code stolen from your favorite tutorial. Okay? But we can rewrite this, and I can show you how to. If Go would have had do notation and monads, you would be writing it like this instead. Should I make it bigger? Maybe we can have it. Oh, I don't need the Go extension. It's okay. So you would just get the result here, and the entire thing about checking the error, early return, all that jazz, you don't do that because the monadic machinery does that for you. Like if you have the maybe monad or optional, as it most commonly known as, you don't handle that. If you have the result monad, you don't handle that. By default, if you get an error, you just do an early return and abort. Already this looks way cleaner, right? It still has this defer, right? Because it's Go. But in a pure monadic language, you wouldn't have defers either, because that's weird. Instead, you would have something like this. You could do the defer, but you would do it in such a way using some sort of monad. So you would call a function, apply it using do notation, but ignore the return value because we don't care, so on and so forth. And that function would probably look something like this. The first value is the value that we actually get here, close. The second value would be the stuff that we would put in then before, right? The magical callback that automatically generated from the sugaring. So you call that, try finally, clean up. This is how you would implement finally in Haskell. And in fact, if you actually look into the standard libraries or in popular libraries, you can find catch, for example, an implementation catch. Something like this. It's much more complicated in the real world, of course, but you know, the idea anyway. Which is kind of cool that you can implement like something like defer, which is a keyword and something part of the language runtime and stuff. But you can do that if you had monads, because they are so powerful. Okay, here I do try final, of course, because you need some sort of exception catching mechanism in the language. You can't get away with that, but still. And then that would become this. If you desugar it, remove the do notation, but still keep the defer idea, it would look something like this. And again, you see all of the returns. Here's the fun, the inner function here inside the defer, and it will call that. And if that explodes, it will always call close, even if this explodes or not. But what's interesting is that if this one would crash, then obviously, I don't know, this inner function might not be called because it's already crashed, right? You don't need to continue there. Yeah. And live coding. There's something called law of the instrument. Another quote, also from internet, also must be true. This time I have a name. When the only tool you have is a hammer, all problems begin to resemble nails. Some might recognize this. The actual quote is a bit longer. It's this. It has the same meaning, but I figured you should know that there's a real quote as well. This is actually a quote, and not just stuff you found on the internet. Monads are powerful. Don't abuse them. Most of the time, it's a for loop. It's fine. Don't worry about it. Like, if you're in Java, don't turn everything into a Lambda just because you can. If you're in a functional programming language, you only have recursion, so use that. If you're not, sometimes it's useful, sometimes it's not. Like, use the tool that's nice. If you have mutability in your language like Clojure, use it. It's supposed to be used, right? Even though immutable stuff is nice, and even though you can find monads even in languages that doesn't have monads, like Go that I showed you here, it's okay. Write the way they do. Prata med bönder på bönders vis. Anyway. And more. I love this. Questions?
Yes, we have one question.
Yes.
Could you implement the? I'll just talk. Could you implement the closing as a part of file open monad?
Yes. Yes, you could.
Yeah.
The way, like it's like inside bind, you actually get the function that you call, right? So that's why you could do try finally. And you could imagine, instead of doing that just for a random function, you could do try, do the opening stuff fun with the actual file handler finally stuff. Kind of like how with statement works in Python. Oh yeah, and that's my, if you want to talk to me again.
Yes,
More silly animations while you...
Yeah, thanks. Really, thank you very much, Max.
Thank you.
I had one more, actually not a question, more like a statement. Resistance is futile. Get ready to be monified.
I love it! Love it! That's right. You can't escape us. Okay, the last thing I should say, I hope I broke the Monads curse.
We so hope absolutely that you did. As resistance is futile.
Exactly.
Yeah. Thank you very much again. Then, almost last slide. Schedule for the spring then, the third meetup will be held on 24th of March. Then we have one in April and one in May, so hope to see you there, everyone. Last slide is summary. It's like, if you want to present at a meetup, please contact me or anyone else of the organizers, Tin or Matthias. If you want to sponsor a meetup, please just ping me. We are constantly like looking for people that wants to present. We're also looking for people that dare to live code, preferably in JavaScript and Monads. I'm joking. Yes, and again, I would really want to thank all the speakers for taking time, making good presentations, and coming here in this time. Thank you very much. And that's it. Thank you for the evening.